Hello everyone, in this video we are going to talk about Robinson annulation. Okay, what is Robinson annulation? Robinson annulation is a combination of three different reactions. The first one is Michael addition reaction, and then it is followed by intramolecular addition reaction, and the third reaction is actually the dehydration reaction, dehydration of aldol addition product. Okay, so we know that Michael addition, both Michael addition and as well as intramolecular aldol addition reaction is going to form a carbon-carbon single bond. So through this reaction, we are going to form alpha-beta unsaturated cyclic ketone. And now why the name annulation? Annulation is ring formation. So because this reaction forms a cyclic structure, it is called as Robinson annulation. Okay, now let's get started with the reaction. So for the Robinson's annulation, we are going to take alpha beta unsaturated carbonyl compound and then react it with a carbonyl compound. Okay. And then through a series of reactions, it's going to form an alpha beta unsaturated cyclic ketone. That's the product that we will get. Okay, so again, as I said before, it's going to be a combination of Michael reaction and intramolecular addition reaction, and then dehydration of the aldol addition product. Okay, so let's get started with the mechanism. Okay, so here is the entire mechanism for this reaction. Right, it's not present in your book, but I definitely want you guys to try this on your own, taking another example. But when you look all at once, it might look as if it's complicated, but if you're going to break it into different sections, then it's going to be very easy. Okay, so when you look into this part right here is actually Michael addition reaction, and from here to here is aldol or intramolecular aldol addition reaction, and from here to here it is dehydration of the aldol addition product. Okay, so we know that the Michael addition uses alpha beta unsaturated carbonyl compound, and here is your alpha beta unsaturated carbonyl compound and your other carbonyl compound. Okay, and you need to form a bond, carbon-carbon single bond between these two compounds. So let's see how it is formed. Okay, so here is your base that goes and abstracts the hydrogen, which is acidic, goes and abstracts the alpha hydrogen on the carbonyl compound and thrusts these electrons onto the carbon, thereby forming the enolate ion. So here is the enolate ion. Once the enolate ion is formed, it's going to go attack the electrophilic part of the carbon, electrophilic carbon on the alpha beta unsaturated carbon compound, and it's going to thrust these electrons on here, and the double bond is going to break, and it's going to thrust the electrons onto oxygen. Okay, and in the next step, where the oxygen is carrying a negative charge, it's going to thrust the electrons back in there to form a double bond, and there is going to be hydrogen addition to the, this double bond is going to break, and the hydrogen is going to get added to this carbon. So this carbon, which is initially CH, is now going to become CH2. Okay, and in the next step, there is another base that goes and abstract the acidic hydrogen. So this CH3 right here, it's actually going to have three acidic hydrogens, and one of those hydrogens will be abstracted here, and that's going to form another enolate. So here is the enolate. And remember, whenever there is a nucleophile and an electrophile in the same molecule, there is going to be an intramolecular reaction. So here is the nucleophile, and the carbonyl group is actually going to be the electrophile here. So the enolate ion is going to go attack the carbonyl carbon, which is present in the same molecule, and thrust those electrons onto oxygen. Now the oxygen with its negative charge is going to go attack the water molecule and abstract the hydrogen. And now here is the product for aldol addition reaction. So this is going to be beta hydroxyaldehyde. That's going to be the addition product in an aldol addition reaction. Okay, and then once the product is formed, we know that it can be dehydrated when heated up, right? So you will heat up the reaction. When you heat it up, water molecule is going to get released. So OH minus, which is a base, will go and abstract the hydrogen again, because these are the two acidic hydrogens that this compound has. So it's going to go abstract this hydrogen, thrust these electrons on here, thrust it here, thereby forming the negative charge on oxygen, and that's going to be kicking back again here, and the double bond is going to shift, and the OH minus is going to primarily take its lone pair of electrons, but it's going to bond with the hydrogen from the water molecule. And do you guys remember what kind of mechanism is this? Yes, it is E1CB mechanism. E1 is unimolecular conjugate base mechanism. Conjugate base mechanism. Remember, in a conjugate base mechanism, you will have a carbanion that is formed. So once after this hydroxide goes and abstracts this hydrogen, this is basically going to form a carbanion like structure. So you can see that there is a double bond right there. So you're going to have a negative charge there, and that is going to thrust back in to form the double bond, and the OH is going to leave, forming water molecule. Okay, and then finally you have your product here. So this is the final product, and the product in Michael reaction is a alpha beta unsaturated cyclic ketone. So in this whole so these are the series of reactions that's happening in Robinson annulation. So maybe I'll just mark this. So this is going to be the Michael reaction. And from here to here is going to be intramolecular aldol reaction, and then finally right here is the dehydration reaction, dehydration of the aldol addition product. Okay, so I hope that you were able to understand the Robinson's annulation, and yeah.